Hey, greetings, Chem and BMB 572. Dr. Bevilacqua here. I want to take you through a little bit of PyMOL, how to install and use it to annotate some files from the PDB. So go ahead and navigate your way to the Canvas page and to the PyMOL page, and then from there to the PyMOL installation. And once you're here, what you'll see is there's 4 different installation files. So choose the appropriate one for your machine, either the Windows files or the Mac file is OS X or the Linux one, and install that. And once you've done that, then you can go ahead and we can go over to the homework assignment. And it tells us here that the first thing we should do is to download a copy of PyMOL, which we've done, and then pull up 2GIS from the PDB. So let me just go back over here to the paper we're interested in. And the way I often find these files is I search on the word PDB, and it'll often take me right to the PDB ID. Now, not always, and not every paper is the same, and not all use PDB, so you sometimes have to look around a little bit. But you get this 4-digit alphanumeric code, in this case 2GIS, and so then we'll go back to a browser and we'll grab a new tab and we'll Google into the PDB, the protein database, which also has RNA structures in it. It's kind of a historical name. We'll go there, and then the way I like to do is just on this line I'll put in the alphanumeric code 2GIS, and then that will take me right to the page. And from here, I just want to confirm that this is the right file, and it looks like it is. It's the S-adenosyl methionine riboswitch. You can scroll down and find other information like the authors, and you can find the DOI for the paper and the reference and so on. So then I usually go over here to download files, and I go right to the PDB format, and I click that, and that will go ahead and download that into my my downloads file. And you may be able to just click that and go right into the student PyMOL. What I'm going to do is from here I'm going to open it with the student, in my case Mac PyMOL, because I have a Mac, and it's going to open it here in this wire or line format. And I really like to use a 3-button mouse, and if you look over in this part you can see the information about button viewing and the different things that will happen when you click on the left, middle, and right and the wheel. So we're going to stick with really simple here, and if I grab my mouse and I use the left one, then I control it around in all sorts of different ways. The middle button, if I push down on the scroll wheel, I can pick up the structure and move it. And then on the right button, that allows me to zoom in and out. So now let's go back to the assignment. And the question asks us to annotate A45 and A46. So the way we're going to do this is basically we need to find A45 and A46. And this view here is going to help us a little bit. And we can see from the secondary structure right here where A45 and 46 are. And so here's 40. You often have to, because the structures are so complicated, figure out which way is 5' to 3', but here's 50. So 41, 2, 3, 4, 45, 46. So it's AA. So let's go back here to PyMOL. And the first thing you want to do is go to Display and turn the sequence on. And now look up here, I can see the different letters. Now there's different things that you could do on top of this if you want. You can change the sequence mode to atoms and get a lot more information in this way. But for our purposes today, just having residues is fine. And then we'll go and find 45 and 46, and here they are. These are these two A's. And now that we have them, they are now over here where it says SELE, which is for the selection. And what I'm going to do is I'm going to go over here and click on some of these buttons. And so the first thing I'm going to do is to click on Rename Selection. And because I have A45 and 46 highlighted, I'm going to change this to A45, A46, and hit Return. And now you can see over here that it's renamed these as A45 and A46. So now that I have that what I can do is go ahead and go here and show them in different ways. So I'm going to say show as sticks, and it'll make them thicker. And if I zoom in and I'm pulling down with the right button and then grabbing the middle button and centering it, you can see here. And if I click somewhere else in the background, it'll deselect them. So now let's say I want to choose a different color. What I can do is go ahead and over here to the C on the color, and I can pick a different color. Like I can go down to the magentas and pick hot pink, and there it is colored like that. Oftentimes though, what we see in publications is we go to color, and we'll color by element, and maybe I'll pick the red carbon or the pink carbon. And so now what you see is the carbons are in red, but the nitrogens are still in blue. They're in atom-specific colors. So let me point that out to you. Here's a blue exocyclic nitrogen, an endocyclic nitrogen, and then phosphorus is this pink color, and of course oxygen is red. There's the two non-bridging oxygens. Here's a bridging oxygen and another bridging oxygen. Here's one that's in the O4 prime, and so on. So so that's really the first part of the assignment. I'm going to do one thing before I go on to the second part, and that is I'm going to zoom back out a little bit, and you can see kind of these different plus signs all over the place, or maybe I can show them a little better with this pointer. Like here's one, and so on. And in other places, if we look really carefully, we can see other. Those are waters, and we can see other things like over here. I can see this species, which is actually a metal ion right there. And so maybe I don't want to look at those, and so I can hide those. And what I do is those are usually over at the end of the structure. And so here is some iridium that I highlighted one right there, so I'll highlight those guys. Maybe I don't want to look at this magnesium ions, and I don't want to look at any of the waters. So I can keep clicking like this, or I can go all the way to the end and just shift click, and that selects all those. And the magnesiums and the iridium those are iridiums, by the way, were used probably to solve the phase as heavy metals, iridium hexamine typically. So now I can go over here to the selection and say hide everything that's selected. And so now if I click over here, you can see that those guys are no longer present. I'm not looking at them. I've hidden them. But I did not hide the SAM. If I click here, I should still be able to see the SAM, and there it is. And so what I can do with that and in that selection is to go ahead and maybe I want to show that as sticks. And you know, there's a whole bunch of different choices here, but that's kind of a nice one that's in there. There's also non-bonded and dots, and you can play around with lots of different options that are present there. And once you're happy with what you see, then what you can do is go in and maybe you want to color that a different color, maybe a yellow or something like that should stand out pretty nicely. Okay, so there's SAM, and there's the adenosine of that. Okay, so that helps us to answer some of the questions, and so let's go ahead and look here at the last one, and that asks us to annotate P1 and P2 in our favorite color. So I'll go ahead and get you guys started on this. So go back over here to the paper, and let me see if I can kind of scroll this over a little bit. And so here is P1, and right there you can see P1, and that stands for pairing 1. Here's the 5' end. And so it starts out GGC, UUA, AU, C, and then it goes over to this A. So P1 is comprised of 2 strands, and it starts out GGC, and it ends AUC. So if I go over here then to our PyMOL, hopefully I can figure this out. There's the GGC, and it keeps going UUA, and go back and just double check. It ends AUC, so AUC. So now I've got all of those. That's the first strand, the 5' strand of the pairing, but there's also a 3' strand which comes down here, and you can see that that 3' strand goes GAU and then ends GCC. So let's go back to that and try to pick that up. So I'm back in PyMOL. This is going to be near the very end of the structure, and so again that goes GAU, and there it is, GAU, and it ended at that CC, so there it is right there, but not the A. Okay, so now I've got those selected, and you can see I've got the whole helix selected here. You can see all the highlights in that region right there. And if I'm not sure whether I highlighted everything or not, or whether the very 5' end is highlighted, well, I'll just scroll back up, and there it is, it's highlighted. So now I can take this SCLE, and I can take this guy, and I can rename that selection, and I'll delete the SELE and rename that as P1 and hit return. Okay, so now I can do some different kind of fancy things with this if I want. So I can show it in different ways, and I'm going to show you one other way, which is to show it as cartoon. And if I do that, then you can see I can see this sort of nice ribbon. I'll kind of zoom out a little bit. It looks a little busy to me. I don't want to look at the lines, so I'll go back into P1. I'll highlight it, and I'll say hide the lines. And so now those are gone. So I hope that this is helpful to you guys. I think this will help you be able to go in and play with the structure and to do a lot of different and fun and useful things. So thanks for watching, and have fun with PyMOL. Bye-bye.